Hey, Wire Monkeys, welcome to another episode of Let's Talk Cabling. Tonight, we're talking about MPTLs. What are they? What are your options? How do you test them? Welcome to the show where we tackle the tough questions submitted by installers, technician, foremen, estimators, project managers, even customers. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube, would you mind hitting the subscribe button and the bell button to be notified when new content is being produced? If you're listening to us on one of the audio podcast platforms, would you mind leaving us a 5-star rating? Those simple little steps helps us take on the algorithm so we can educate, encourage, and enrich the lives of people in the ICT industry. Wednesday nights, 6 p.m. Eastern Standard Time. Did you hear that? Wednesday night, 6 p.m. I've shifted it. It's no longer on Thursdays. We do a live stream on TikTok, Instagram, Facebook, all over the place, where you get to ask your favorite RCDD, and you know that's me, your favorite RCDD questions on installation, design, certification, estimation, project management. I even do career path questions. But I can hear you now. But Chuck, I'm driving my truck at 6 p.m. on Wednesdays. I don't want to crash and get into an accident. That's okay. I record them, and you can watch them at your convenience. And you can find them at letstalkcabling.com. And finally, while this show is free and will always remain free, if you find value in this content, would you click on that QR code right there? You can become a Patreon member. You can buy stuff off our Amazon links. Or you can even become a corporate sponsor as well, too. We're always looking for corporate sponsors. We're also taking advertisements as well. So as I said, today we're exploring a topic that seems to be gaining a lot of traction in our industry. And what are we talking about? MPTLs, Modular Plug Terminated Links. Now, here's the thing. Some people might call them direct connection. We'll talk about that here in a minute. Doesn't matter. Whether you are an installer, a project manager, an estimator or designer, this episode is going to have packed and valuable insights for you. So let's get right into it. In part one of today's episode, we're going to compare what is a traditional horizontal cable to an MPTL. We're going to explore the standards that address the MPTL and discuss what types of network equipment that uses those MPTLs. But we have to start off with, how is a MPTL different than a traditional horizontal cabling? A traditional horizontal cable typically consists of a cable that runs from the cable from that port on that patch panel through the ceiling, or maybe under the floor, to that connector on that faceplate. A couple episodes ago, I talked about what those all were. Telecommunications outlet is the connector on the faceplate. The faceplate is the work area outlet. And then the area that it serves is the work area. So that then a patch cord is going to plug into some type of a device. Most commonly found for traditional horizontal cabling, it's going to be a telephone or a computer or a printer. The reason the standards have us set up this way is because it allows for easy reconfiguration and troubleshooting. And doing it this way gives you a nice, reliable, and repeatable, that's key there, repeatable connection to allow for that MAC work, the move, edge, change work, or maybe system upgrades. So again, those connectors are rated to up to sometimes as much as 2,500 cycles. Now, an MPTL, on the other hand, that allows for the horizontal cable to be directly connected with a modular plug, an 8P8C, often referred to as an RJ45. And we can get in a conversation about if that's actually correct or not. But that's a different show. So what you can do is you can crimp that 8P8C modular connector on it. Some people call them ice cubes. And you can connect it right into the end device. This eliminates the need for that outlet or that patch cord where it might be unsafe or maybe not feasible to put a faceplate or a traditional service mount box. Think about devices mounted on poles. Since the MPTLs are not susceptible to as many insertions as that traditional jack configuration we talked about, this direct connection is allowed. And this causes a lot of confusion in our industry. One of the first low voltage installers to quickly adopt this type of method of terminations was our AV installers and our security installers. You see, prior to 2018, terminating cable this way was in direct conflict on how the standards, the ANSI standards, and the best practice manuals instructed us as technicians in the field how to actually do this. The advantage of an MPTL is that it could potentially help by reducing signal loss and improving performance by minimizing the number of connection points. See, the standards that really guide this are going to be the ANSI TIA 568.2-D standard, and it was released in 2018. When they released that standard, it now recognizes MPTLs as a valid cabling configuration, and it also provides us guidelines for installing and testing that MPTL. The standard was developed in response to the increasing use of devices like wireless access points, security cameras, and industrial sensors, and a bunch of other stuff, which benefit from direct cable connections. What are some of the types of devices, though, that MPTLs can use? There's lots of them out there. Probably the most common one you're going to come across, the wireless access points, or the WAPs. Sometimes industrial sensors, where they're monitoring production, they're monitoring tolerances, IP cameras, power over Ethernet, HVAC, and many other IoT devices requiring a direct attachment type of connection. For example, in modern office with open ceilings, MPTLs can connect wireless access points directly to the network, avoiding the cluster of patch cords and wall outlets mounted in the ceiling. And think about this as environments inside that ceiling. Similarly, security cameras are installed in hard-to-reach places for many reasons. One, so people can't get to them and mess with them, and two, so they can see everything. So they're going to be mounted in these hard-to-reach places, which can benefit from the simplicity and the reliability of MPTL terminations. And now a message from our sponsor.
Big or small, local or nationwide, Fortress Telecom is your go-to partner for all your connectivity needs. With our expertise in low-voltage cabling, bidirectional Tier 2 fiber certification, copper certification up to Cat 8, and Wi-Fi site surveys using Ekahau Sidekick, there's no project too challenging for us. Count on Fortress Telecom to deliver top-notch solutions tailored to your business, wherever you are across the nation. Visit fortresstelecom.com or call us today to start your seamless connectivity journey. Fortress Telecom. We are secure IT. Let's get back to the show.
Welcome back from commercial break. Moving into the second section, let's talk about the processes of terminating MPTLs. We're going to cover the use of modular plugs, the differences between pass-through and traditional types of connectors, and also some more reliable options out there for you. When you start using modular plugs, also known as 8P8C, again, you might hear them called RJ45s. Probably one of the most common ones used is, the simply RJ45s. Right? And now they offer a lot of great types of advantages. When you talk about the 8P8Cs, they're available in two major categories, pass-through and traditional. You want to start an internet argument? Say one's better than the other. I get it. Some people prefer the pass-throughs. Some people prefer the traditionals. But the fact of the matter is, they are both tried and true ways to terminate MPTLs, as long as you follow some key considerations, which we'll talk about shortly. Now, the pass-through connectors, they allow for the individual wires to actually pass through the connector and actually come out the front of the connector, which makes it easier to verify that you have the right correct wiring order before you go ahead and crimp it. Remember, you can use T568A or T568B, as long as you do the matching termination on the other side. This can be especially useful for ensuring that your accurate termination and reducing the risk of wiring errors. Because if you make a mistake on a modular plug, you have to cut it off and re-terminate it. And that's wasted time and wasted materials. However, if they're not properly trimmed and crimped, the excess wire can cause damage to the performance. However, if not properly trimmed or crimped, the excess wire can cause performance issues, or maybe even dangerous situations, especially with power over Ethernet devices, by shorting them out. Now, traditional connectors on the other hand, require precise wire alignment before you crimp them, and as the wires are trimmed inside the connectors. So you have to make sure that you get them all cut evenly straight across. Now, this can be a little bit more challenging, but when it's done correctly, it's going to result in a clean and reliable termination. Both of these can be suitable termination methods, provided you install them in a manner dictated by the manufacturer and you maintain your crimper. Many technicians aren't aware that those crimpers have to be maintained. Many of them are going to require them to be adjusted as they go through their life cycles and crimps because they just become loose. Some of them even require blade replacements as they age. If you don't take care of your crimper, you're going to start getting sloppy mod-in connectors, and that's where the issue comes to play. The issue is not pass-through versus traditional. The issue is, how well have you maintained your crimper? So let's talk about the impact on MPTLs. The choice between the pass-through and the traditional connectors can impact the performance and reliability of the MPTLs. Pass-through connectors are often easier, but they may introduce a variability that if not terminated correctly. Traditional connectors require more skill, but they can provide more consistent results. Again, they're still good. They're both good connectors. It really kind of boils down to, what are you most comfortable with? But there are more reliable termination options. Many professionals will turn to high-quality connectors from reputable manufacturers. For example, the field terminated plugs. And there's a couple of them out there. But two of my favorite are going to be the Leviton 6A plug, known for its robust design and ease of use. This plug ensures reliable connections in your MPTL installations. Panduit plug. This modular plug is designed for performance in high-speed networks and provides reliable terminations for MPTLs. Both of them are really good. And of course, then I already mentioned the Platinum Tools EZ-RJ45. That's going to be a popular choice amongst installers for pass-through design, making it easy to verify that the wire is in order before you crimp it. And let's be honest, the price of a EZ-RJ45 is a lot less than a field terminated plug, but it's not going to be as reliable. It's not going to perform to the same level as those field terminated plugs. An issue often experienced by installers when installing field terminated plugs is, as I mentioned, those field terminated plugs can be rather large. The most common complaint I hear, this being a problem, is on wireless access points, especially those that have closely spaced ports. You see, there's just simply not enough room for those two large field terminated plugs to sit side by side. Another options are couplers. Now, couplers are offered by many manufacturers where you will literally terminate your horizontal cable on one side of the coupler. You'll take one of your factory-made patch cord, cut the end off that patch cord, and then terminate on the other side of that coupler. And now you have a factory-made patch cord going into that wireless access point, thus eliminating those space issues. Additionally, consider using high-quality termination tools. Stay away from those cheap punch tools that you buy at the big box stores. Yeah, they might last for 50 or 100 jacks. Buy a good quality punch tool because you're a professional. This is how you make your living. When you do that, you ensure that there's consistent and reliable connections, thus reducing the risk of network issues going down the line. And as always, make sure that you use the same category components through the entire link. If you mix and match category components, your performance will be limited to your weakest link. And you may even experience some testing failures. I literally just did a 2-part series on my live streams last week on the most common types of copper test failures and their most common solutions. Make sure you go back and watch that.
Hey everyone, we're taking a quick break to talk about an essential resource for anyone interested in the vast world of physical security. Whether you're a seasoned professional or just starting out, you'll want to tune into Security Today. Hosted by Bear, this podcast dives deep into everything security related, from insightful articles and thought-provoking philosophies to the latest trending topics in the industry. Every episode of Security Today is packed with information that's crucial for staying informed and ahead in the field. Join Bear as he explores complex topics with ease, making even the most intricate security concepts accessible to everyone. Follow the journey on Instagram and Twitter at UncleBear_ and at Security Today Podcast. Now let's dive back into our episode.
Welcome back to part 3. We're going to focus on the proper setup for testing MPTLs. And we're also going to address some common considerations. The proper setting up for MPTLs. Now, this is where a lot of people get confused. Testing MPTLs involves verifying that that cable meets the performance criteria that specifies in the standards that I talked about earlier. To properly test an MPTL, you're going to need a cable tester that supports MPTL configurations. Check out the AEM Test Pro 100, the Fluke Networks DSX 8000, the Softing Wired Expert 4500, and I'm sure Viavi and I'm sure the other ones have them as well too. Just verify that your tester is capable of doing MPTL testing. This test should include an adapter for modular plug at one end and standard equipment at the other end. The correct way to test that MPTL is to put your permanent link adapter inside the telecom room, plug it into the port on that patch panel. And then at the work area outlet side, you want to use a patch cord adapter. I'll say that again. A patch cord adapter. Notice I said a patch cord adapter, not a channel adapter. They're different. The reason you want to use a patch cord adapter is because the measurement's actually going to start at the beginning of that mod end connector. A channel adapter, the measurement actually starts on the other side of the mod end connector. If you're crimping this on, the most likely thing that's wrong with this whole entire link is that connector that you crimped on. And if you use the channel adapter, you're not even measuring that. So you got to use a patch cord adapter. Here's the kicker though. That patch cord adapter has to match the rating of the cable plant. So if you're doing a Cat 5e for an industrial sensor, you have to use a Cat 5e patch cord adapter. If you're testing a wireless access point and you're running Cat 6a cables to them, you have to use Cat 6a patch cord adapters. You know, another issue that people run into a lot is because they know that most testers are backwards compatible, meaning a category 6A tester can test Cat 5e. That's not true with patch cord adapters. So if you have 5e MPTLs, 6A MPTLs, you're going to need 2 patch cord adapters, one for each rating of performance of cable plant. Patch cord adapters are not really cheap. They're going to run $400 to $700 per pair. So make sure that you have them. And many manufacturers won't give you a warranty if you test an MPTL with a permanent link adapter on one side and a channel adapter on the other side. They're going to require you to test it per the standards. By testing that way, you're going to ensure that you aren't testing it per the ANSI TIA 568.2-D standards for testing. And it's going to cover your bases that you need to do, like near and crosstalk testing, insertion loss, and return loss. Now let's talk about some common misconceptions about MPTLs. I hear a lot, MPTLs don't require testing, or all the customer wants is performance-based testing, like a bit error rate test. If you're trying to get a manufacturer warranty, you're going to have to test it per the standards, period. You should be testing it you should be certifying it anyway. That we can get that conversation on another show, but you should be certifying them anyway. You see, MPTLs do need to be tested. They should need to be tested and make sure that they meet the network requirements for that type of network, for that level of performance that it's being designed for. Another one I hear, and we talked about this earlier, pass-through connectors are always better. Well, pass-through connectors are easier to use. They can introduce some variability if they're not properly terminated. It's essential to understand that the pros and cons of both pass-through and traditional connectors, and choose the right ones for your application. Some people are better at pass-throughs. Some people are better with traditionals. Use the one that you are comfortable with. Another one, MPTLs are only for wireless access points. Well, MPTLs are very popular for connecting wireless access points. Again, I mentioned earlier, that's not the only device out there. They can be used for any IP camera, digital signage, industrial sensors, PoE, HVAC, all of that stuff can be terminated with MPTLs now. And doing the MPTL is going to be flexible and efficient cabling solution for those types of devices. And lastly, I hear quite often, MPTLs are not limited to 295 feet. Come on, let's be realistic here. Proper testing is going to ensure that link will support the intended network applications without any issues. It's also important to note that testing should be done after the installation is complete, and if you come across any failures, they really should be addressed right away. This is going to ensure that network will perform reliably from the day that you turn it over to the customer. Well, that about wraps up today's episode on MPTLs, or Modular Plug Terminated Links. I only covered really the basics of MPTLs and its comparisons to traditional cabling standards that govern it and how we terminate those MPTLs. I hope you found this information valuable and hope it helps you in future installations. Hey, but don't forget, subscribe to Let's Talk Cabling for more insights and tips on the low voltage industry. And if you have any questions on topics that you would like us to cover, drop me a message. So until next time, keep those cables neat and those connections strong. Knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.